Alright, this is video number 2 for the second page of your review, so let's get going. Question 11. Which of the following sets of segments can create a triangle? So remember, in order to make a triangle out of 3 segments, this is not Pythagorean theorem yet. This is just any triangle. It doesn't have to be right. It's A plus B has to be bigger than C. A plus B together has to be bigger than C by itself. So look at part A. 3 plus 5 is 8. Is that bigger than 8? No, they're equal. All right, but it can't be equal. It has to be larger. So that's not a triangle. B, 5, 8, and 10. 5 plus 8 is 12. Is that bigger than 10? Yes. So B is a triangle. C, 6 plus 10 is 16. Greater than 20? No. Not a triangle. So A, no. B, yes. C, no. Okay? A plus B bigger than C. Just for any triangle. It doesn't have to be a right triangle. We're not a Pythagorean theorem on this question. What angle classification would a triangle with side lengths 5, 12, 13 create? So now we are using Pythagorean theorem to determine if it's acute, obtuse, or right or equiangular. You really won't be able to determine if it's equiangular unless all 3 sides were the same, because that would be equilateral and equiangular at the same time. So that's right off the bat, no. But we have A, B, and C. First, we're going to check A squared plus B squared. So 5 squared plus 12 squared, 25 plus 144 is 169. And we check C squared. 13 squared, 169. These happen to be equal. That makes this a right triangle. Remember, if C squared is bigger, it's going to be obtuse. If A squared plus B squared is bigger, it's going to be acute. But when they're equal, it is a right triangle. 13, angle QRS is 94. Find the measure of QRT. You look at QRS, you follow those letters from Q to R to S. So this whole angle from here to here is 94 degrees. Okay, they want you to find QRT. QRT is the top part here. All right, now not to get all confused with these colors. So the whole thing is 94. You can see obviously that this little piece is 34. This should be a simple 94 minus 34 gives us 60 degrees. Okay, don't get thrown off by the 3 letters. Follow them. That's an angle symbol, not a triangle. Q to R to S for the first one, or Q, R to T. Okay. 14. Are lines and M and N parallel? So on the front page we knew the lines were parallel, those are transversal. What were all those angle relationships? This one is it is the converse of that. This one says, I don't know the lines are parallel yet. If one of those angle relationships exists, then I can say that's true. So look at what we have here. You have these 2 curves. These angles are alternate exterior angles. Okay? They are on opposite sides of the transversal, one above, one below, and they are outside the 2 lines. Okay? One of our rules is, in the converse, if alternate exterior angles are congruent, then the lines are parallel. These are congruent, so yes, they are parallel, and that's your justification. Alternate exterior angles are congruent. Okay? So, again, before we go further on, it may be good to remember what angles should be what. So, alternate interior, alternate exterior, those are congruent along with corresponding. Okay? And consecutive interior, consecutive exterior, or same side exterior, those are supplementary and equal to 180. Okay? All right, question 15. Is triangle WZY congruent to triangle WXY? Justify your answer. Well, if you look here, well, first of all, let's remember what were our shortcuts. We have SSS, SAS, ASA, AAS, and HL. Now, this is congruence, not similarity. You are going to have to remember the difference between those two. Okay? Looking at the picture, there are no angle measurements that are given to you, nor are there like vertical angles that you can know, oh, these are congruent. So anything really that's involving some sort of angle, probably a no. SSS and HL can only be used if it's hypotenuse leg. That's what it means. It can only be used in a right triangle, so it's not that. So look, we have this congruent to that, that's one side. That congruent to that, that's another. And then they share this. Remember that reflexive property. All three sides are congruent, so these are congruent. It's a yes by SSS congruency theorem. Okay. All right, so now on to question 16. Which two postulates or theorems do not show triangle congruence? All right, it's AAA, AAA, and SSA. Okay, neither of those will show triangle congruence. Yeah, so you just got to memorize those, right? AAA, and of course the word backwards. All right, so now 17. In the figure below, what is the value of x plus y? So several things we got going on here. I'm going to make this a little bit bigger so we can write in it. We need to find x, we need to find y. Now, if you look over here at this part of it, this x is an exterior angle. We have an exterior angle theorem which tells us that the exterior angle, x, is equal to the sum of the two what we call remote interior angles. Remote means it's the two that it's not next to, so it's next to this one. These two it's not next to. Those are remote. Okay, if you add those up, it's going to give you x. It's similar to that problem on the first page where it talked about the supplement of the third angle, right? X is the supplement of the third angle. So x is going to equal 80 plus 40 or 120. Again, if you don't remember that rule, you can get there the long way, which is finding this third angle and then finding what makes it add up to 180, just like that other problem. Okay. Over here, because that's 40, this is going to be 40. And then, hey, look, there's that rule again. 40 plus 70 is going to give you y, which is 110. So now y plus x, or x plus y, 120, and 110 is 230 degrees. All right, if G is a centroid of triangle ABC, AD is 30, CG is 15, and AD, this is perpendicular, crosses at 90 degrees. That's that right angle down here at D. It's AD perpendicular to CB. What is the measure of AG? Now, in all honesty, this information is kind of extra. Okay, the key pieces are centroid and AD is 30. Now, these are the special segments of a triangle, the perpendicular bisector, angle bisector, the median, the altitude. They meet at points called the centroid, the orthocenter, the incenter, the circumcenter. You're just going to have to go back at those notes and kind of look and try to remember them. The key here is that the centroid cuts this line from A to D. Right here where it cuts AG to be 2/3 the length of your line and GD to be 1/3. And that's true for all of them. Like for C to E, C to G is 2/3, G to E is 1/3. B to G is 2/3, G to F is 1/3. Right? So it cuts it into those fractional pieces. So if AD is 30 and you are looking for AG, you simply need to take 30 and multiply it by 2/3. All right? And that's going to give you 20. That's AG. So this would be 20. That would be 10, 2/3, 1/3. 19. In the diagram, segment DF is a midsegment of the given triangle. Find the length of BC. Mid-segment connects midpoint, so that's a midpoint, that's a midpoint, that's also going to be a midpoint. But DF here is a mid-segment. Two things. It is parallel with the third side of the triangle, this side over here, right? They're parallel. We could draw those parallel arrows on here. But more importantly, to solving this problem, the mid-segment is 1/2 the length of the third side, right? So DF is 1/2 BC. Okay, now we know DF, we don't know BC, so we're pretty much going to work backwards here, right? It's like saying 12 is 1/2 of what? Well, to cancel out this 1/2, if you're thinking about it algebraically, you multiply by 2, because 2 times 1/2 is 1. Those cancel out and you have 1x. And 2 times 12 is 24. So this is 24 because when you cut it in half, you get 12. And last one on this page, number 20, deals again with that exterior angle theorem that we saw way up here in problem 17 a couple times. So again, remember, it's the exterior angle is equal to the sum of the two remote interior. This is the angle it's adjacent to. These are the remote interior. So 3x plus 72 equals 120. Okay? And then just do some algebra, solve it however you need to. Right? Minus 72 minus 72. 3x equals 120 minus 72 is 48. 48 divided by 3 is 16. So there we go. That's the second page of the review. The third page will be on the next video, and we'll finish it up there, and we'll see you on Monday.